students, good morning everyone. This is the first lecture related to class 10 physics for chapter number 11, that is current electricity, and about reflection of light and refraction of light. I just taught each and everything. If further any confusion you have, then you can ask, but today I am just going to explain about the current electricity. In current electricity, total nearly 10 to 15 terms are given. So I will explain today nearly 5 to 7 terms in first lecture, and remaining terms will be in second lecture. So in this lecture, just try to understand about each and everything of basic concept of electric current. So first of all, in electric current, the concept of electric charge. Just before defining the electric current, you have to know about the concept of electric charge. Electric charge means, definition of electric charge very easy. The terms that can be used to express the concept of electric force. The place where the electric force is available, then there is a concept of electric charge. Electric charge means the quantity which is applying electric force on any other charge quantity. I will say that the terms which is used to represent electric force, and here electric charge are of two types. The terms are quantity which is used to represent or to express the concept of electric force. And here mainly two types of electric charges. Types of electric charges. Mainly two types. Number one, positive charge, and number two, negative charge. Here positive charge means charge on proton. The value of this positive charge, that is plus 1.6 into 10 power minus 19 coulomb. This is the value of positive charge. Similarly, the value of negative charge, that is charge on electron. This is the fundamental charge. Here the concept of charge on proton is what? Fundamental charge. Same as concept of charge on neutron, not charge on electron, charge on an electron. Simple here, E minus power. So 1.6 into 10 power minus 19 coulomb. Here with negative sign. Whenever charge taken with negative sign, then charge on an electron. Electron means the fundamental entity of charge. It means charge can never be further divided into a smaller part than the charge on electron. It means elementary charge or fundamental charge or basic charge, that is charge on electron, and the charge on electron value, that is 1.6 into 10 power minus 19 coulomb. Here minus sign means charge on electron and here plus sign means charge on proton. So after classification of charge, the next concept here, the unit. Here unit representing what? That is C means coulomb. In 1 coulomb, how many electrons? Very important questions. In 1 coulomb, how many electrons? So here charge on 1 electron charge equal to 1.6 into 10 power minus 19 coulomb. This is the value of charge on 1 electron. But in 1 coulomb, how many electrons? Just see, 1 coulomb is equal to 1 upon 1.6. This is the value of charge only here in positive sign taken. Why? Because the magnitude concept is essential in the calculation of the number of electrons. Clear? So 1 upon 1.6 to 10 power minus 19 electrons. And here this minus 19 10 power raising upward, then will be what? 10 power 19 upon 1.6. So here 10 upon 6, 16 here into 10 power 19. Further 100 upon 16 into 10 power 18 electrons. 10 power 18 electrons. And when we simplify this one value, then we will get what? Very easy concept. That is equal to 16 6 is 96, and further 40, then 4 after 0 point here 62 is 32, and then 80, then 65 is 80. 6.25 into 10 power 18 electrons. This is the concept of number of electrons in 1 coulomb charge. Clear? Very simple concept. In 1 coulomb, total number of electrons, that is 6.25 into 10 power 18 electrons. Just after the concept of electric charge and the types of electric charges, very important concept, that is the starting concept of this chapter, that is electric current. So just note down all these terms. Just see, after the concept of electric charge, the next one concept is electric current. Very easy concept. Electric current. Electric current means the time rate of flow of charge. Definition here in exact way. It is very important. The time rate of flow of charge through conductor. When the end point of conductor connected to potential difference. Let's see. The time rate of flow of charge through the conductor when potential difference is applied across the ends of the conductor. Clear? Here the concept of potential difference, that is very easy. Just after this I will explain about the potential difference and potential concept. First of all, try to understand the time rate. Time rate. The flow of charge. It means charge whenever divided by time. Then this is concept what? Electric current. I equal to Q by T. And here I equal to Q by T, where Q is equal to NE. Q is equal to NE, where N is integers and Q means total charge. Total charge, where E is charge on an electron. Charge on an electron. Clear? And the concept of this one, very easy concept. Coulomb, that is the unit of charge, and second is the unit of time. Then the SI unit of electric current, RMS unit, SI unit of electric current is Coulomb per second or ampere, where 1 ampere is equal to 1 coulomb upon 1 second. 1 ampere is equal to 1 coulomb upon 1 second. Clear? Very simple. Just try to understand. When 1 coulomb of charge flowing through the conductor in 1 second, then the current flowing through the conductor is said to be what? 1 ampere or 1 coulomb per second. Here, why the concept of potential difference is applied? Because when the flow of electron without any potential difference, then the flow of electron is said to be random flow, and in case of random flow, there is no definite current flowing from left to right or from right to left, or you say that from one terminal to another terminal. It means the current value will be 0, because in that condition the thermal average speed will be 0. Thermal average velocity will be 0. But when we apply potential difference across the ends of the conductor, then electrons are drifting from negative terminal to positive terminal, and there are so many electrons. So whenever we take the average speed or average velocity of electron, then there is a concept of drift speed, and that drift speed defines what? The concept of flow of electric current. Because in case of whenever no potential difference is applied, then electrons are moving, but the direction is not a fixed direction. That's why their random movement never constitutes what? Electric current. It means current is defined only whenever the ends point of conductor joined with potential difference. And the concept of potential difference, very easy, just see potential difference concept. Potential difference, nothing, just the concept of work. Very easy concept. Potential difference, the concept of work. And just before understanding about the potential difference, you have to understand about the concept of potential. Concept of potential, just see potential, or you say that electric potential. Electric potential. Electric potential simply used as potential. Just see about electric potential. Suppose you are bringing a charge, that is test charge, and bringing from infinity to a particular point A, a test charge you are bringing from infinity to a particular point A in the electric field of a source charge. This is the source charge, and this one is test charge. The concept of electric potential, just try to understand, very easy concept. The work done in bringing the test charge from infinity to a particular point in an electric field, and the condition is what? Without acceleration. Without acceleration. So see, the work done in bringing the test charge from infinity to a particular point in an electric field, without acceleration. Is defined as electric potential. Clear? Very easy concept. The definition of electric potential, and here formula, that is W upon Q naught is equal to what? G. W upon Q naught. This is the test charge, and this is work done in bringing the test charge. This work done is in bringing this test charge from infinity to a particular point A in the field of this source charge. Clear? And SI unit of electric potential, SI unit of electric potential is volt or joule per coulomb. Joule per coulomb. Clear? If the work done is 1 joule in carrying 1 coulomb of charge from infinity to particular point A, then 1 volt is equal to 1 joule upon 1 coulomb. Clear? Simple concept of definition of electric potential. And just electric potential difference is similar to this concept. First of all, listen again about the concept of electric potential. It is nothing, just the concept of work done. Concept of work done, one is the condition, you have to bring the test charge from infinity from a particular point A. Clear? And this work done in bringing the test charge from infinity to a particular point A is defined as what? Electric potential. तो सिंपल है, समझने के लिए बस एक बार ध्यान सुनिए, किसी भी टेस्ट चार्ज को इन्फिनिटी से किसी पर्टिकुलर पॉइंट ए तक लाने में जो वर्क होता है, उसी वर्क को हम लोग क्या कहते हैं? इलेक्ट्रिक पोटेंशियल कहते हैं. इलेक्ट्रिक पोटेंशियल होता क्या है? W अपॉन Q नॉट. W किस में मेजर किया जाता है? जूल में, और Q नॉट दैट इज इन कूलम. सो SI यूनिट, that is however unit 1, that is what? Volt, and second, that is what? Joule per coulomb. So if 1 coulomb of charge whenever carrying from infinity to particular point A having 1 joule of work done, then the concept of potential is said to be what? 1 volt and then 1 volt is equal to what? 1 joule upon 1 coulomb. Clear? Just note down this one. After this I will explain about the electric potential difference. First of all, note down this one. Just after the concept of electric potential, the next one concept is electric potential difference. Just see, electric potential difference. Simply, this one also called potential difference. No matter either electric potential difference or potential difference, both having same concept. Here, taking electric field due to source charge. Here this one Q at point O, that is what? Source charge. Source charge, and we are just bringing the test charge from point A to point B. From point A to point B with reference to this point O. Here the source charge held at point O, that is Q, and here test charge bringing from A to B. And the concept of potential difference, let's see, when a test charge bringing from one point to another point, one point to another point in an electric field, in an electric field without acceleration, then this work done, is defined as potential difference. Very simple concept. Let's see, VAB is equal to VA minus VB, and this one equal to what? WAB upon Q naught. Simple. Only the concept of difference. Here VA minus VB. Between potential at point A, if greater, then VB will subtracted. So VA minus VB is equal to what? WAB upon Q naught. Here potential formula very simple. When you will just study in class 12, then potential formula will be what? Will be equal to 1 upon 4 pi epsilon naught Q upon R. It means V inversely proportional to R, and here inversely proportional means whenever distance less then potential greater. Here at point A, this distance is what? R1, this distance is R2. Are you saying this distance is RA and this one is RB? Here RA is less than RB, so potential at point A is greater than potential at point B. Clear? So when we just bring the test charge from A to B, then potential will be differ from A to B. Here at point A, potential is greater, at point B, potential is smaller. So VA minus VB gives the concept of potential difference between 2 points A and B. Clear? तो सिंपल है, क्या करना है, बस किसी भी टेस्ट चार्ज को, पोटेंशियल डिफरेंस हमेशा याद रखिए, पोटेंशियल डिफरेंस में टेस्ट चार्ज को किसी इलेक्ट्रिक फील्ड के पॉइंट ए से पॉइंट बी तक ले जाने में जो वर्क डन होता है, उसी वर्क डन को हम लोग क्या कहते हैं? इलेक्ट्रिक पोटेंशियल डिफरेंस VAB इज इक्वल टू VA माइनस VB इज इक्वल टू WAB अपॉन Q नॉट। क्लियर। ये WAB क्या है? वर्क डन इन ब्रिंगिंग द टेस्ट चार्ज फ्रॉम A टू B। जब डिस्टेंस कम होगा तो पोटेंशियल ज़्यादा होगा। इस Q नॉट की डिस्टेंस सोर्स चार्ज से RA जो है वो क्या है? कम है। किससे? RB के कंपेरिजन में। तो RA जब कम है तो पोटेंशियल एट पॉइंट ए क्या होगा? ग्रेटर होगा। क्यों? क्योंकि ये क्लास 12 में फॉर्मूला ड्राइव किया जाएगा पोटेंशियल का ड्यू टू ए पॉइंट चार्ज पोटेंशियल एट एनी पॉइंट आर ड्यू टू ए सोर्स चार्ज पोटेंशियल एट एनी पॉइंट एंड टेस्ट चार्ज V इज इक्वल टू व्हाट? 1 अपॉन 4 पाई एप्सिलॉन नॉट Q अपॉन R। तो R की इनवर्सली प्रोपोर्शनल है क्योंकि 4 पाई कांस्टेंट है, Q ये भी कांस्टेंट है, एप्सिलॉन नॉट एक स्पेशल कांस्टेंट है जो क्लास 12th में ही समझ में आएगा। अभी समझने की कोई मतलब नहीं है उसका। उसको कहते हैं इलेक्ट्रिकल परमिटिविटी ऑफ फ्री स्पेस। तो ये कॉन्सेप्ट जानने की इनवर्सली प्रोपोर्शनल है, मतलब डिस्टेंस जब घटेगा तो पोटेंशियल क्या होगा? बढ़ेगा, और जब डिस्टेंस बढ़ेगा तो पोटेंशियल क्या होगा? घटेगा। तो ये पोटेंशियल डिफरेंस का बहुत सिंपल कॉन्सेप्ट है। इसकी भी यूनिट क्या होती है? सेम होती है जैसे पोटेंशियल की यूनिट थी। तो ये SI यूनिट is volt R। जूल पर कूलम। कभी कभी इस पे कॉन्सेप्चुअल क्वेश्चन पूछ देता है। कैलकुलेट द वर्क डन। कैलकुलेट द क्वेश्चन नोट कर लीजिए, बहुत इंपॉर्टेंट क्वेश्चन है। कैलकुलेट द वर्क डन इन ब्रिंगिंग 5 कूलम ऑफ चार्ज। In bringing 5 coulomb of charge, calculate the work done in bringing 5 coulomb of charge from point A to point B on equipotential surface। अब इक्विपोटेंशियल सरफेस कह दिया है तो ये श्योर है कि A पे जो पोटेंशियल होगा वही पोटेंशियल B पे होगा, चाहे वो पॉइंट A और B कहीं भी हो सरफेस पे। जब इक्विपोटेंशियल सरफेस कह दिया है तो ये कॉन्सेप्ट क्लियर होना जाना चाहिए कि पोटेंशियल दोनों पॉइंट पे सेम है। पोटेंशियल जब सेम है तो पोटेंशियल डिफरेंस क्या होगा? जीरो होगा। पोटेंशियल डिफरेंस क्या आ जाएगा? VA माइनस VB इक्वल टू 0। क्लियर। देन WAB क्या हो जाएगा? Q इंटू 0 इक्वल टू 0। बहुत इंपॉर्टेंट कॉन्सेप्ट है, ऐसा पूछा जाता है कॉन्सेप्चुअल क्वेश्चन में कि व्हाट विल बी द वैल्यू ऑफ वर्क डन व्हेन 5 coulomb of charge and any value of coulomb of charge carrying or you say that bringing from point A to point B on equipotential surface. Then in case of equipotential surface, whenever you have to calculate the work done, then always the value of work done will be 0. Clear? So just after this concept, the next one concept, very important concept of this chapter, that is Ohm's law. Ohm's law. Just see. Very easy concept and very interesting concept also. Ohm's law. Very simple law. Actually, Ohm's performing so many times the particular experiment and concluded the result that current directly proportional to potential. It means the flowing of current through any conductor is directly depends upon potential difference. I will say that potential. So Ohm's concept containing two terms, potential and current. These two terms are directly dependent on each other, but here the statement that is given current directly proportional to potential difference, but reversing of this one statement also taken, that is I proportional V given, so reversing V proportional I, then the concept of resistance used there. The reason behind this one, because the current is not a dominating factor, the dominating factor is what? Potential. So just see, at constant temperature and potential, at constant temperature physical condition, not potential, at constant temperature, and physical condition the current flowing through a conductor, the current flowing through a conductor is directly proportional to potential difference. Applied across the ends of the conductor. Clear? Very easy. That is I proportional V. You say that V proportional I. Clear? Here reversing of this one, I explain just why necessary, because potential is what? Dominating factor. Potential is dominating factor. So V is equal to Ri, where R is constant and is known as resistance of the conductor. Resistance of the conductor. Resistance of the conductor depends upon so many concepts, that is length, temperature, area, and so on. So about dependency of resistance we will discuss in next lecture, but in today's lecture that is sufficient about the resistance concept and its unit. So just see where R is equal to here V upon I, and with the help of this one unit, SI unit of resistance equal to what? Ohm. That is honorable unit. R. Volt per ampere. Volt per ampere. Clear? Anyone we can write down. Just see with the help of this formula. When current of 1 ampere flowing through the wire, when current of 1 ampere flowing through the wire at a potential difference of 1 volt, then the resistance developed in the wire is said to be what? 1 ohm. Always remember, when V is equal to 1 volt and I is equal to 1 ampere, then R must be equal to 1 ohm. It means 1 ohm equal to 1 volt upon 1 ampere. Clear? The concept of resistance, that is very easy. You will just practice out and try to solve out numerical based on this. And one of the more thing related to this Ohm's law, when we plot a graph potential versus current, then we obtain a straight line passing through origin, and that is the ideal graph. That is, in a special case, always obtain a straight line, but when we practically just draw the graph, then there is always a curved line will obtain, having somewhat amount straight, no matter. But we will draw in actual practice that this is current axis here, and this one is potential axis, along y axis and current along x axis, then we will obtain what? Resistance. R is equal to V upon I. Clear? Resistance, that is R is equal to V upon I. The slope of this graph representing resistance. So that's all for today in first lecture. In second lecture, we will discuss the remaining terms of this chapter, electricity, in complete and detailed way. So thank you. Have a nice day.